Hi, my name is António GODINHO. I'm an invited teacher at the Technology and Management School of Oliveira do Hospital and the Coimbra Business School, both institutions of the Polytechnic Institute of Coimbra. And I'm here to present this work about an evaluative study comparing the performance of RESTful Web APIs created on .NET and Java Spring Boot. The reasons behind this work, I work as a systems administrator and also the web developer over 20 years, and we had to redo all our web platforms because the ASP.NET Web Forms was no longer maintained. So there were no standard testings that could help us to compare technologies for different APIs. All the tools that exist usually only exist for the get method, not for the all CRUD operations of the web API. And also because I believe this method can help to compare different technologies and understand their limitations, and can also pinpoint existing coding problems or on specific endpoints. Well, this work is based on a previous work that was presented on the EEI Good Text 2003. The test battery it's composed by 4 different tests. The load test is to determine if a system is meeting performance goals. Stress test, how the system behaves in the extreme conditions, maximum capacity of system in terms of throughput. Spike test is the variation of the stress test. It's like how the system will behave under denial of service attack, for example. And the soap test is a very long test, 4 hours. To identify bugs related to race conditions. Database does not exhaust the storage space. The same for logs, and if external services that depend on the web API don't stop to work after a certain amount of time. The testing scenario uses an Nginx, is it as a reverse proxy that allows connections to both APIs with different URLs. They both connect to the same database. All the servers use Prometheus. Prometheus is an open source system monitoring and alerting toolkit that allows gathering stats, in this case CPU and RAM, and also this provides a data source to Grafana. There is a open source time series data query charts visualization tool. So this allows the creation of charts, but the logs from Nginx cannot be read directly to Grafana. This work is done by Fluentd, so everything can be visualized beyond charts. As the tool used for the test is K6 that allows using JavaScript files. We can set up the duration and the amount of users, so we can do all the tests on the test battery, and also the method and the endpoints that we are trying to achieve. By running the K6 on Bash, we can provide the file that we are using, and also we can set up the statistical values that we want, medium, percentile 90, 99, and afterwards we can read everything on console like this, medium 1.65 seconds, 1.9, and also very important, the number of HTTP requests failed. In terms of the technology used by Java and .NET, they are pretty similar. We have the domain classes. They are translated to the databases. Well, the object relational model just on Java uses the JPA layer, and the JDBC API and the driver, and the identity framework provides exactly the same thing. So the database used had 2 tables, one for the department with the name and department ID, and another one for the employee with the name, salary, and the department ID used as a foreign key for the first table. So straight out of the gate, the .NET just print out the SQL command sent to the database. So you can see here that we'll just retrieve everything about the employee and also the department using the left join. Well, the Java did something strange. it cannot retrieve nested attributes. So it just retrieves the information from the employee, and then afterwards, using the department ID, just did another query to the database. So that was too much traffic through the network, that using an external database server, that this could lead to misleading results. But one thing that could be done was to specify the SQL command straight directly on the endpoint. That's exactly what I did, so that I could have exactly the same command on both technologies. After a few hours running without any requests on idle, we can understand that the Java requirement in terms of RAM was almost the double of the .NET. On the get load test, we can see that the demands on terms of CPU is pretty much the same, yet the Java requires around more 200 megabytes of RAM, and we have pretty similar results in terms of latency. On the get test, we can see that the differences between the CPU requirements, .NET requires more CPU, around more 14%, but on the RAM side, Java requires more. But the biggest difference is on latency, where you can see that on .NET percentile 90, we have 14.55 milliseconds to 300, and on the 99 percentile, we have 38 milliseconds to 700. On the get spike test, you can see that the .NET requires more 8% of CPU than the Java, but the Java requires around more 40% of RAM. But the biggest difference is on the latency, where the performance is pretty average on the .NET, around 84 to 192 milliseconds from the percentile 90 to the 99. The Java performance is really bad, because when comparing one versus the other, is 1.45 seconds and 2.6 seconds. On the longest test, we can see yet again that the CPU requirement is pretty much the same. Yet the amount of RAM required by the Java is around the double. And on the latency, once again, we have the .NET on the 10.90 milliseconds to 2520 milliseconds, but the Java, it's 132 to 217 milliseconds. And we can see on the table that the number of requests per second of the .NET is more, and we have 0 HTTP requests failed. On the post, we still have the same behavior on the CPU and RAM, but still we have worse performance from Java in terms of latency. On the P90, we have 30.25 to 900, almost 1 second, and 778 on the percentile 99 to 2.1 second. But the biggest issue here is the number of HTTP requests fail. It's around a little bit above 15%. On the post stress test, we have exactly the same behavior. The latency of .NET is between 30 to 78 milliseconds on percentile 90 and 99. On the P90, we have 900, almost 1 second again, and the 99, 2.1 second. And once again, we have almost 39% of HTTP requests failed. On the post spike test, we have exactly the same behavior, but on the spike test, of course, the demand is higher. .NET on P90 is 1 second to Java 2.37 seconds, and 1.18 on P99 to 4.75. And once again, the biggest issue here is the 36% of HTTP requests failed. The post-soak test has exactly the same results, where on the P90 we have .NET with 24.79 milliseconds to 1.27 second, and on the P99 we have .NET with 54 milliseconds to 2.41 second, and once again we have a very high number of HTTP requests failed. The put and delete methods were pretty much similar to the get method, where we have more CPU requirements from the .NET and almost the double of the Java. And on the latency, we have almost similar results from the Java to the .NET results. On the delete load tests, we can see that again we have problems on the behavior on the Java API. We can see that the latency of the .NET is around 75 milliseconds, while Java goes to 190, or in the 99 percentile from 878 milliseconds to 2.28. But again, we have around 50% of HTTP requests failed. Both APIs struggle with the delete stress test, but once again, we can see here from the latency on .NET from 285 to 800, all below 1 second, and Java goes from 5.55 seconds to more than 6.5. And again, in this time we have HTTP requests fail on the .NET part, 45% against almost 78%. So all across these tests, the Java API is underperformed by the .NET. And the one with really bad results for Java was the spike test on delete. Still, for the .NET, we have bad results because we have almost 50% of HTTP requests fail, but almost 99% of HTTP requests on Java side. And also the timings were way worse for the Java, while on .NET 351 milliseconds to 600, and while on Java it goes way above 5 seconds. On the soak test, once again, we have better results for .NET. We have the latency between 32 and 43 milliseconds, while on Java goes from 8 seconds to 8.9. And we have around 10% of HTTP requests failed on .NET and almost 85% on Java. Well, once again, Java has issues on these tests. These tests, they show that the .NET performs very well and better than Java. There are some concerns about how Java manages posts and delete requests, particularly on rigorous testing with a huge load, as clearly indicated by the amount of HTTP requests failed. It means that from this test that the .NET is more able to handle high volumes of traffic and time critical situations. This study confirms the importance of testing all CRUD operations. For example, on this test, if we exclude the post and delete operations, we could conclude wrongly that both APIs behave almost similarly. So I believe that this, for an accurate estimate how the API handles trafficking certain operations, it's required to test all the CRUD operations: create, read, update, and delete. Otherwise, the results could be wrong. Also, I believe that the test battery that is constructed helps to achieve all the different scenarios of a web API. It can match one API versus the other, and can help companies to decide in which direction, which technology they could use as a development tool. Thank you very much.